Hi class, this is our 11th online lesson and our second and the last for this topic, statics. So in the first lesson of statics we studied about single forces, okay, resolving the vertical forces and horizontal forces with the component of forces and all. Now we'll go to connected particles, more than one particle going through pulley, something like the question which is on the screen now. Okay, so we'll be, and the same thing we studied in dynamics, you know that formula F equals to mu r, the frictional force. Mu is the coefficient of friction into r. So this second part of statics will be dealing with those same concept that we studied in dynamics earlier. Okay, let us take this question now. This is the question from the chapter review actually. It's a higher order question, so pay attention. It's on page 126, question 4. A particle q of mass 5 kg rests on in equilibrium. So this is how you will know in exam that this question is on statics and not on dynamics. It's not moving on a smooth. So there is a smooth inclined plane, so there is no friction. And now the thing is, they did not give us the angle directly as 30 degree, 40 degree, something like that. They gave us the angle in terms of trigonometry. Tan theta is 3/4. So don't do tan inverse of 3/4 to find angle and go into decimal and all. We have to work with exact values. So we work, okay, let us take, first of all, let us take the forces which need to be drawn. You can try on your own first, pause here and then check. Okay. So these are, first of all, the weight will be acting downwards, okay, and the weight of, there are two objects. This object here is P, this object here is Q. They said P is of mass 2 kg in the question, so the weight will be 2 into gravity. And they said Q is of mass 5 kg, so this will be 5 into G. And the string, we know the tension will always direct towards each other and tension will always be same because the string is same, okay. And the reaction force will, because it is on a surface, there will always be a reaction force perpendicular to the surface. There is an extra force F in the question which is neither horizontal nor vertical, so we need to resolve. That is why there's, you see this blue forces here and the green forces here is to resolve the weight. I hope everything is clear with the forces. Now let us start. First of all, look at this, the trigonometry involved in this question. Tan theta, they gave us tan theta is 3/4. You remember in trigonometry we studied, if you know one trigonometric value, one trigonometric ratio, you can use Pythagoras theorem to complete a triangle and find all other trigonometry. If you know any one trigonometric ratio, you can find all the remaining. So now if tan is opposite over adjacent, correct? So this is theta, opposite over adjacent, Pythagoras theorem will give you 5. So sine is opposite over hypotenuse, 3/5, and cos is 4/5. So this is what we'll use. In place of sine theta, we'll use 3/5 as an exact value instead of taking the decimal angle. Let us start. Now it's very important, because there are two particles, it's very important that you mention that you're working at P or you're working at Q. The order does not matter. One can start at Q also. So at P, if I resolve downward force as positive, so this 2G will be equal to T, or T equals to 2G, and hence we got the tension. Tension is 2G. Now let us come to Q. Okay, at Q, so mention like this in exam. If I resolve this horizontal, again as I told you, always take the surface as horizontal and R as vertical. So if I take this horizontal force, there is a horizontal force here, you can see my pointer, and there is a horizontal force here. Both are acting in rightward direction, and this is horizontal force in the leftward direction. So this together will balance this. That's why T plus F cos theta is 5G sin theta. In place of cos theta, we'll substitute the exact value, the whole cos theta. Remember, it's not only theta, so don't only substitute theta as 4/4. The entire cos theta will be replaced by 4/5. The entire sin theta will be replaced by this 3/5. And there is, this entire equation has only one unknown, F. You just do simple mathematics, you got F 12.3 Newton. Now let us go to vertical component. Let's take a new slide. Okay, this is just copying from the previous slide. Let's go ahead. So now we resolve this. So this force is upward, and both this green here and this blue here are downwards. So this plus this will balance this up. So that's why R will be this plus this. We know F from here already. We know sin theta. We know 5G G is a constant. Cos theta we know. We substitute. You got R. So this is Easy. But the second part of this question, where which is tricky, and pay attention now. And if you remember, the same question I've asked you to solve in one of the previous dynamics video. I asked you to solve. Now I am giving the solution here with a different example. See, the question says find the force acting on this pulley. So what is the force experienced or acted on this pulley? Okay, definitely there is a weight pulling it downwards here, this force, and there is a weight here. So there is a force. Okay, I'll draw the forces here. See, look at this. With although the tension is in the upward direction, but when we talk in terms of the pulley, the force exerted on the pulley is experiencing a force in this downward direction and this downward direction, correct? So with respect to the pulley, the direction of the forces will change. So now it has one force acting in this direction, one force acting in this direction, and we want to know the resultant of these two forces. If you remember in the class when we were doing vectors, we studied how to find resultant of more than one vector. What you can easily do is move one vector parallelly, because vector is something which has to do with magnitude and direction. So direction means I can move a vector parallelly anywhere. The direction will not change. So what you do is where the first vector ends, try to move your second vector to start from there. So see, this is what I have done. I just made this dot 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 to show you that I will move this red vector t. I'll move it here parallelly. So this is the first vector. You see here where this ends, I'm making the second vector, this one, to start from there. And from your initial start to your final end, when you draw a straight line, that is your resultant vector. And if you look at this diagram, this is an isosceles triangle. Okay, and again there is one more thing, this theta. Now because we are going into angles and all and length, if you do tan inverse this angle, this theta is 36.9, and we know this angle is 90. You look at my pointer now. So if this is 90, this is 36.9, I can find this 53.1 easily, correct? Now see, because this vector t, this, look at my pointer now, is moved here. So I can say that this angle where my pointer is now, this angle and this angle will become co-interior angle. So co-interior angle means this angle where my pointer is now will be 180 minus 53.1, and that is how I got this 126.9. Hope everything is clear. Now let's move ahead. You know two side, you know the angle. We studied in P2 that we can use cosine rule in maths to find this resultant vector. Now let us look at cosine rule. So cosine rule, using cosine rule, I can say r square is this t square plus t square minus 2t into t cos 126. You know t already from here, t is 2g. Just substitute, everything is known, do square root, you get r as 35 Newton. This is as far as the force acting on the pulley. So the force here we know, but the question is not only the force acting on the pulley, and they also want us to find the angle. Very simple. This is the isosceles triangle. So if this is 126, this angle x and x will be same. I wrote x just to tell you that they are base angle of an isosceles triangle. So I can do 180 minus this, divide by 2, I can find x. And if I know x, I know the bearing will be 180 plus x. So I'll know the bearing on which the force is acting on the pulley. Let's take that slide, that part. So x is 180 minus this thing divided by 2, so this x is 26.9. so the bearing of this is the resultant force, correct? This is on a bearing of 180 plus that, which is 207 degrees. This was a long question, but it will be of 13-14 marks in exam. Let's go ahead. Okay, this question, a packing crate of mass 10 kg rests on rough ground. Now this is rough, so you have to take care of friction. There's book and so on. It's not a big deal. Let us draw this. Read the question first and then look at, you can try to draw your own diagram first and then look at you can pause the video. Okay, so together with the mass of the crate and the book, it is 10 plus m. So 10g plus mg is the weight. Because there is a surface, there will be a reaction force. There is a horizontal force, they said, of 147 Newton acting, and the friction will always oppose that, correct? So this is our diagram. Let us solve. Okay, so if I resolve r rightward, I can say 147 equal to f. I wrote in a different way. 147 minus f equals to 0 is the same thing. Let us take the other component now, vertically. So vertically, this is the upward force and this downward force will balance. Instead of taking R equals to 10G plus mg, if I take it on the other side, it becomes this. Let us solve now. So now F is 147. Now because whenever there is R and F in a question, go to mu, use this formula, F equals to mu R, okay, and mu is given in this question 0.3 here. So we know the coefficient of friction is 0.3. That's why R will be 147 divided by 0.3. So reaction force is 490 Newton. And now let us come here. You can find, you substitute R here, you can find mass. Simple. This is your R, 490, and that's it. You got the mass, 40G. And the second part of the question is, what is the modeling assumption? That is particle. Together they are particle. The assumption is that the crate and the book may be modeled as a particle. Clear? Let's take a new question. Okay. Now you try to do this question on your own. Pause the video, read the question. Okay. Limiting equilibrium is still in equilibrium. Okay. Try to do this question on your own. I am drawing the diagram, the force diagram, the diagram with the forces and all, with the components and all. Okay, it is rough. So and they gave you mu 0.25. Use this information. F equals to mu R. There is a force upward, there is a force downward, rightwards there is one right and two left. Use all of this to form equations and solve. Next, similar situation. Again, I want you to read this question. Okay, pause the video, read, try to draw the scenario, then you will see the diagram now, and then you will solve on your own. Again, the same thing, mu is given, F equals to mu R. Okay, so the angle is 35, so this will also be 35. This is opposite. So these are the forces, the weight, the friction, and the resolving component. Use upward, rightward, downward forces, form the two equations and solve them. Okay, you will get the equation like this. Both the equations are here now. Okay, solve on. Now everything is there. You just need to do some mathematics. That's it. Okay, now let us take this question. A box of mass 0.5 kg is placed on a plane which is inclined to an angle 40 degree. Okay, the coefficient we have mu is 1 by 5. The box is kept in equilibrium by light string, vertical, everything. 20 degree here, 40 degree here. Let's the two questions. If the box about to move up and about to move, see, it is just about to move, limiting equilibrium, object is still at rest. So all the questions of limiting equilibrium, you should know that you're working with statics. Okay, about to move up the plane, still in uniform, just about to move. Okay, about still in equilibrium. Let us take this first. Let us draw the forces. You can pause your video, try to draw all the forces and the components. Okay, let's check. So because there is a surface, there will be a reaction force perpendicular. Okay, if it is about to move up the plane, the friction will be downwards. Okay, because it is about to move up, friction will be down. This weight will be downwards, mg. These are the two components of the weight, and this extra force T, these are the two components. This 20, this is opposite, that's why sine 20, cos 20. This is 40, this is opposite, this one is opposite, that's why sine, this is adjacent, that's why cos. We know mu. Okay, let us form all the equations. Let us go to the next one. Okay, so the same diagram I have drawn here so that you can compare. Now if I resolve like this, upward, there is one upward force here, there is one upward force here, and there is one downward force. So, and this two are up, this is down. See, that's why this plus this two are up, this plus this will balance this one. I'm just making R the subject. This is just one way of doing it. There are simultaneous equation. There are many ways of solving simultaneous equation. I'm just trying to do one way. If you find some other way easy for you, you can do that. Now resolving rightward forces, now horizontal forces. There is T cos 20 and horizontal force F and 0.5 this 0.5 g sine 40 are in the opposite direction. So this plus this will balance this. That's why t cos 20 is 0.5 g sine 40 plus f. Again, I'm just making f, as I said, this is just a different approach of solving simultaneous equation. I'm making r the subject, f the subject, and using this formula f equals to mu r. In this formula, if you make mu the subject, you can say mu is f by r. You know mu is 0.2. We know f is all of this. I'm writing that up, r down. And now you have equation. And this entire equation, you have only one variable t. So you have one equation with only one variable, cross multiply, take all the t on one side. I have taken both the t on the right hand side, brought all the numbers constants without t on the left hand side, take t common, because there are more than one terms with t, you take t common so that all of this can go down in the denominator. So t will be this 0.1 g cos 40 plus 0.5 g sine 40 divided by this entire bracket, that will go down, and hence you will get t as 3.9 Newton. I hope you understood. That's it. We are done with statics. There's only one more chapter left. Okay, goodbye.